Okay, so today we're going to talk about plate tectonics. Just before we start, let me just... If you have any questions about anything during the lecture or any of these slides, if anything's confusing, don't hesitate to ask or send me an email if you have a detailed question, and I'll get back to you as soon as I can. Okay, so plate tectonics. What are plate tectonics? Plate tectonics basically came from the theory of continental drift. And if you haven't heard of this before, it's basically the theory that these land masses, which we all live on, and the ocean are floating on top of a liquid inner part of the earth. So these landforms can actually move very, very slowly across the earth's surface, and that's because you have the crust on the outer layer, and then you have underneath it you have this lava magma, and this top sheet can actually move across, and generally it moves very, very slowly. But this theory basically came from the thought that originally on Earth there was one gigantic landmass, and we call that Pangea, but you don't really need to know that. Just know that if you were to basically stick all the continents in the world together, kind of like they fit like puzzles. You can see that kind of roughly you can actually fit them together into this one big landmass. And if that's not enough evidence, they actually found fossils at these connecting points. So if you take the modern world that we have, these are all separate, right? We have North America and South America are connected, but they're like way over here. And then you have Africa would be over here, Australia would be over here, you know, Russia, the Middle East, Southeast Asia over here. And if you were to put them together, you have these areas where fossils, the same fossils, have been found from two different continents. And if you put them together and say, I can't remember what animal it is, but it's kind of like an armadillo. I don't know if you guys know what an armadillo is, but you can look it up on Wikipedia. They found this armadillo-like creature in South America and in Africa, this fossils from this creature. So they think that at one point these two were connected, and then slowly over time these land masses kind of broke apart and formed the world that we know today. So it's pretty cool thinking about, we're kind of just on these floating land masses. They move so slowly we can't really tell that they're moving, but we know that they are. There's instruments to measure how fast, and certain plates move faster than others. So it says here this was supported by fossil and rock type evidence. So either they found animal skeletons that were the same, they looked the same, or they found rocks that were very, very similar. But now these are thousands and thousands of kilometers apart, but at one point they were the same backyard. Okay, so convection currents. This is basically a really good diagram of the top sheet of the Earth, and then this kind of lava mantle that's just below the surface, and this is what the plates kind of float on top of. And because there's many different plates, and we'll see later the specifics of different kinds of plates, this liquid is moving in this kind of circular pattern, and it's some of it's moving up. As this moves out, then more molten lava moves up, and this is the Mid-Atlantic Ridge, and there's different types of plate boundaries where one plate meets another plate, and the main two types are convergent and divergent. So this is a divergent plate, and divergent just means they're moving apart, and as the molten material comes up and goes through this plate. As these move apart, it starts to make more crust. And as that's happening, there's other convergent areas, and this is a great example. South America and its oceanic coastline has this plate, and it's kind of going underneath this other plate. And as it goes underneath this other plate, because of this current is sucking it down, then it kind of melts and turns into lava. While this is making new crust, this crust is disappearing. So that's how we have kind of new crust being formed all the time and old crust being turned back into lava, and it's this big cycle. And what does this mean? How do we know what this is, and what does it mean? Basically, we can look at the formation of mountains, these big trenches in the middle of the ocean, these different kinds of volcanic ranges, islands in the ocean. Everything can kind of be explained in terms of tectonic plates. So the force responsible for plate movement, can anyone tell me what they think the force responsible for plate movement is? A big hint is that it's in big bold letters at the top of the slide. Yeah, convection currents, which is just the current of this liquid kind of liquid magma underneath the surface of the Earth. So pretty cool stuff. So plate boundaries. The following two slides show maps of current major plate boundaries and their relative motions. By the end of this lecture, hopefully you'll be able to describe various landforms created by the plate movements. So that just, we're just talking about these mountains here, these ridges, and what kind of plate boundary this is. So we have the South American plate and we have the African plate, and they're connected, but they are moving away from each other. So this is divergent. Don't be scared of this document here. It's kind of confusing, but really just pay attention to these arrows. This is the Pacific plate, and most of this is underwater. So the ocean lies on top of the crust of the Earth as well. So when we see these kind of diagrams about plate tectonics, they don't really care about the ocean. They just care about the crust underneath the ocean. So the Pacific plate is basically the plate tectonic that is underneath the Pacific Ocean, and there's another. It's not the entire Pacific Ocean, but it's definitely most of it. And you have this other plate on the border of South America, and we see on this boundary here what's going on. We have these arrows pointing away from each other, so we know that these are divergent fall boundaries, and they're going to create these valleys underwater, and we can see these gigantic valleys underwater, and this is where new Earth crust is being formed by those convection currents. The liquid magma is being pushed to the surface, and this is going to be new crust being formed. And really close to this, this is called the Nazca plate. It connects to the South American plate, and actually, I don't know if you guys don't know this, the whole western side of South America is very, very big mountains, and these are called the Andes. And the reason that they're there is because this is a convergent boundary. You can see by these two arrows here that this ocean plate, so this is ocean, is connecting with this land plate. And you can see this red line here and these arrows, okay? And what that tells us is that this plate is going underneath this plate. So this plate is going underneath. This is the same coastline I was just talking about. This is South America, and this is the Nazca plate. And this is going underneath. It's being sucked down by these convection currents going underneath, and it's forming these mountains. And we'll go into more detail about that. it's also forming a big trench right off the coastline. So if you want to go swimming and you kind of feel like you can dive down to the bottom, if you swim out far enough from South American coastline, you're going to get in really, really deep water. And that's because of this plate that's going underneath this plate. And we'll talk about it a little bit more, but that's called subduction, when the plate goes underneath this other plate. Okay, so we can kind of see this all over the world. This is really fascinating, and geologists have worked really hard to figure this stuff out. You know, we have the Antarctic plate down here, this huge plate, and we can see that most of its boundary is divergent. So these two arrows moving away from each other just mean that new crust is forming, and the whole time these land masses are moving in different directions, and you know, they're colliding, and when they collide, one plate goes underneath the other plate. They can also be moving side to side. So that is a new type of boundary we haven't talked about. It's called a transform boundary, and that's when the plates hit and they kind of move this way. So you have the divergent, you have the convergent where one goes underneath, and then you have these transform boundary. And the transform boundary is pretty interesting because it can build up tension over time. So these plates are kind of like they're trying to move and they can't, and there's all this resistance for them moving, and then they just pop. They pop like that, and that's an earthquake. So on the coast of California in the U.S., they have a lot of earthquakes because this is a transform fault boundary right there. San Andreas fault is a really famous transform fault, and it creates lots of small earthquakes, not big ones. They say that they're due for a big one, but we don't know when that is. But generally, these are very small earthquakes, and it comes from the transform fault. They really want to move, and then pow, they just move really quickly, and it creates an earthquake. So yeah, just know that this little red arrows pointing means that this plate is going under this plate. You have the same kind of thing. You have this Indian-Australian plate, and it is subducting over here. The Pacific plate, kind of, you know, on the coast of Japan, is subducting as well. You can see the little arrows. And this is just a non-color version of a similar thing we were just talking about. You can see that South America is moving to the left, and the Nazca plate is moving to the right, and you know, the Nazca plate's going under, just like we talked about. Okay, so this is a really helpful slide. You might want to copy this or take a note. This basically just defines what we were just talking about. The three types of boundaries. You have the divergent boundary, which is moving apart. You might want to write down, this is creating new crust. Okay, and convergent boundary, they're moving together, and one plate is subducting. When you have a convergent boundary between the sea and the land, one plate is going to be subducting, and we'll go into more detail about convergent boundary because really these are the most exciting. These are how volcanoes are formed, giant mountains, you know, islands in the middle of nowhere. They're mostly formed by convergent boundaries. And then you have transform fault boundary, which is like the San Andreas fault on the coast of California, and that's the plates that kind of move side to side from one another. So this is an important slide. Okay, so let's just go over a little bit about what happens to the landscape with these different types of boundaries. There's just a little bit of vocabulary here. It should be pretty easy, but it's when you have a divergent boundary between two land plates. So this is plates with no ocean on top. Then you get what's called a rift valley. Okay, so this is kind of just like a low area, and it's because as the new crust comes up, it's just kind of like flattening out, and it creates this valley, and it's kind of got these broken pieces because the magma is hardening and creating new crust. So when it first comes out, it kind of looks like this. So the East African Rift, you can probably see. East African Rift, you have these really divergent land-to-land boundary here, and then they create this rifts. Okay, convergent boundary, which is my personal favorite because you get all these epic things happening. This is a convergent boundary of two oceanic plates. So this is ocean and this is ocean. And the same kind of things happen. You have one plate going underneath the other plate, and this plate that's going underneath is called the subducting plate. So this is the subduction zone, and it forms this big trench just like off the coast of South America, off the western coast of South America. And in the process of going underneath, it creates islands. This crust is pushed up enough that the land actually comes and sticks out of the ocean and creates these islands. And an example of that is the country of Japan. That's how Japan was formed, is by this action. One plate going under another plate and created this gigantic island called Japan. So this is pretty fascinating stuff, and we can go into as much detail. I could do an entire class on how this specifically works. Really, it's the friction between the subducting plate and the rest of this crust, and it creates this kind of bubbling effect, and it pushes the land up and pushes this stuff out of the water and creates these islands. So just some key terms. We have island arc, which is kind of what happens here. You can't see from this particular slide, but when you have two plates kind of together, sometimes they're like in this shape, and so the islands kind of form in an arc shape. And you can see this with Japan. If you just look at the country of Japan, you can see it's kind of curved, and that's because it's an island arc. And off the coast of Japan, just the same as we were talking about with South America, there's this really big trench, and it's very deep, and it's basically directly a result of this subducting plate creates this trench. What's that? Really? Yeah. Okay, so yeah, you get earthquakes here because, again, whenever you have two plates moving against one another, they have this friction, and sometimes they can't move, and then pow, they pop, and this pop creates a shock wave that we call earthquakes. So yeah, I guess they had one yesterday. I'm not sure the details, but yeah, it's very common to have earthquakes on convergent and transform plate boundaries. When you have two plates moving away from each other, you don't get earthquakes because they're moving apart and you have this magma coming up. But anytime you have these two plates sliding against each other, you're gonna get earthquakes, and it's just a big part. And it'll be there. It'll never stop. We'll always have earthquakes. So yeah, island arc, trench, and you can just, someone said, well, give me an example of an island arc. Huge example, Japan. Okay, so this is probably my favorite part about plate tectonics is volcanoes. I don't know if you guys really like volcanoes, but gigantic mountains spewing lava is just really cool for me. I don't know why. And this happens when you get an ocean. So before we're talking about two oceanic crusts. Now we're talking about continental crust and an oceanic crust. And typically what happens in this situation is the oceanic crust will go below the continental crust. It will subduct underneath the continental crust. So just subducting. It's just the same word we used here, subducting. And everyone will, you'll sound really smart if you start using this word, when you're hanging out with your friends or whatever. Just the oceanic crust is subducting underneath the continental crust, and it's creating gigantic volcanoes. And I'm from Oregon in the United States, and this is a classic example of this oceanic subduction with continental crust. And this is a convergent plate boundary, just like we talked about before. Um, so, this we can go into detail again. The friction between this creates lava, and the lava is pushed up, and it actually eventually spews out the top of these mountains. They're formed, and then they spew out, lava and wreak havoc and explode and blow the tops off of entire mountains, and it's really, really exciting stuff. So yeah, well, it also forms a trench. So anytime you have a subducting plate, you're going to get this trench that's forming. And you can kind of see how that happens. You have this, it's going underneath, and it's kind of making this thing, and then, this is the trench right there. So just the line along the... But this is typically going to be a little bit shallower than you'd find on two oceanic crusts that are converging. But yeah, it's just important to know that you get a volcanic mountain range every time. You get a volcanic mountain range. You get, when you have ocean meeting land, continental crust, and they're convergent, they're moving towards each other, you'll have volcanoes. And all along the coast of South America, the Andes, that is also a volcanic mountain range. Those are volcanoes as well. And you can kind of tell volcanoes because they have, a lot of times they'll have these jagged look to them, and they'll have, some of them will be flat on top because literally the top has been blown off millions of years ago. And when mountains are kind of forced to be created in this way, they look all jagged. They look really sharp. So yeah, Cascades and Andes. So Cascades are on the coast of Northern California and Oregon in the U.S. on the west coast, and Andes also on the west coast. And we can kind of go back here and look at why that is. So you have this huge Pacific plate and this Nazca plate, and right here, I'm sorry, not Pacific plate. You have the Juan de Fuca plate, which is this little green plate right here, and it is subducting. This is Washington, Oregon, Northern California right here on the U.S., and it is subducting. It's convergent with the North American plate, and then you have the Nazca plate, which we already talked about. And so this whole area along the western part of North and South America is volcanic mountains. So that's pretty cool. Talked about that. Okay, so now let's talk about two convergent land plates. Okay, so you have continental crust meeting continental crust. Okay, what's going to happen? It's like a face-off. Who's going to subduct? Well, the answer is no one's going to subduct. It's basically the land folds upon itself, and it's compressed, and it creates these more mountains. So if you have continental and oceanic, the oceanic plate will go underneath. If you have two continental plates, it's like, two huge wrestlers. They can't, pin another one down. They just kind of call it a stalemate and create this gigantic mountain range. Some of these mountain ranges that are continental crust are some of the oldest mountain ranges and some of the biggest. And if you can think of the biggest mountain in the world, that is a folded mountain. And the whole Himalayan mountain range with Mount Everest is folded mountain range. And this is by land continental plate meeting land continental plate. So you can kind of see what happens here. These things kind of just compress together, and they kind of form this mountain range like that. Typically, this process takes longer, as you can imagine, because you have two plates meeting, and they're kind of working against each other, and they're kind of just like crumpling together, like if two cars had a head-on collision, they kind of would do something like that. But an oceanic and a continental plate boundary, one is going underneath, so it has less resistance. It's just it's smoothly going underneath, and then these mountains are forming. So this is the oceanic one, this is the continental one. It goes underneath and forms these mountains. Here we have just these two, and they create this mountain range. So typically this takes longer. The only thing you really need to know from this slide is that this is called a folded mountain range, and it's from two pieces of continental crust coming together. So that's called convergent plate boundary. Okay, so now we have the San Andreas Fault, which we just talked about, and this is by far the smallest type of plate boundary. Most plate boundaries are either convergent or divergent, but sometimes, if you have enough puzzle pieces moving together, you have pieces that just kind of move parallel to one another, in opposite directions. And that's what this is. This is talking about the Pacific plate and the North American plate. So this is oceanic crust meeting continental crust, and they're moving in opposite directions, but they're not moving towards each other. They're moving kind of parallel to each other in opposite directions. And like I said, this creates a little bit of tension, but not a huge amount, and creates a high frequency with a lot of small earthquakes. So high frequency just means a lot over a short period of time. And in geology, a short period of time could be like 1,000 years. So just know that a long period of time would be like 100 billion years, but a short period of time could be. We're not talking about 10 minutes. We're talking about 1,000 years. So yeah. Just three types of boundaries: convergent, divergent, and transform. This one's the rarest, but we do see it off the coast of California. It's most famous. Okay, so this is another great slide. I would definitely take this home and look at it after this. This is just exactly what we've been talking about. Places where plates move apart are divergent. When they diverge, they form a rift valley. Okay, this is important because this means when it says when continental plates, this means two land plates. So no ocean is involved with the rift valley. Okay, so all this places where plates move apart. This is ocean, land, both at the same time, two different ones. All of these, when they're moving apart, no matter what, they're called divergent. When two land plates move apart, they form a rift valley. When two ocean plates move together, they form an island arc like Japan. This says the Appalachians, which is true, but I prefer to think about the Himalayas, and this is continental plate collision is Mount Everest, gigantic mountain. Everyone wants to climb it because it's so huge. Appalachians are they're good, but they're much smaller. So you could say Appalachians or Mount Everest, formed mainly by continental plate collisions. They're a folded mountain range. So this is like we were talking about, the two plates kind of come together and just kind of fold and create mountains. And this is from the first slide. The force moving these plates is the convection currents. So let's just go back to the first slide, or I guess third slide. So yeah, it's important to know that all these really amazing geologic events are happening because of what's happening underneath. So what's driving the movement of these plates is this liquid, kind of the current. If you think of this as water, this is kind of like the current that magma kind of has, and this kind of current, you can see this arrow is moving around this way, and you can kind of picture this plate being sucked down into this kind of current, and as this comes around, this pulls some magma towards this way, and this pulls some magma this way. Then you have this heated material that's expanding and rising and kind of, you know, forming new continental crust over here. So you can kind of think about this as the main driving force for the movement of plate tectonics. Um, so yeah, if you have any questions on any of these slides, feel free to send me an email, um, or just you can get these slides and download them off the website, and it should be really helpful for you to study. Any of this stuff that you don't understand, um, if you email me, or you can talk to me, you know, in a little while when we actually meet in class, and we can definitely go over anything you have any questions about. Okay, well, I'll see you soon. Okay, bye. So what do you mainly fish for out there? Like marlin, or what's the?
Yep.
Yeah.
Yep. When we sport fish, probably mainly fish for like pelagic species.
Oh, okay.
Yeah. Fishing a lot of the rivers as well, for flathead and mangrove jack and stuff like that. Just like river species fish.
Were you working on a boat or running a boat kind of thing?
I have done that. Like I said, it's more of like a hobby and also professionally fished as well. Yeah, on trawlers and things like that.
I'd love to go marlin fishing. Sounds amazing.
Yeah, it's a bit expensive.
Yeah, I was reading about that. You know, everyone wants to catch the 2 ton or the 1 ton marlin. I guess like the biggest one ever is like 1,800 pounds or something ridiculous like that.
Yeah, I'm nothing like that. I know what you're saying, but no, nothing like that.
Yeah, I did a lot of fly fishing back then in Oregon.
Oh, okay.
Fishing.
Yeah, like underwater fish and stuff like that. Yeah. No, here you go. There's some, I've actually worked on this boat. I tried to tell the kids what I was doing, and this is where I'm from.
Okay.
So Mooloolaba here. So you're in Brisbane. Brisbane's about here.
Okay.
This is Stradbroke Island.
Okay.
Did you ever hear?
Yeah, yeah.
Yeah. Okay. So this is Stradbroke Island. Yeah, I think Brisbane's all in here. And the Gold Coast is down on this country here. Yep. This is the boat I've worked on, Tweed Seeker. So just those trawlers.
Yeah.
Yeah. This is obviously only fishing night time. So this is what you do. This is the captain. He's winching up with these winches. And here comes the nets and stuff that are winching up. And the nets behind these boards. They go along the bottom of the ground.
Okay.
shrimp for you, or do you feel like you still really love it?
Oh no, you love it, especially out there when it's so fresh. You know what I mean? Yeah.
Sure,
It
sure.
makes you